This is Precalculus Onramps, and it's review. And I'm going to do the 3 questions on the review that have to do with derivatives first. Here is derivative of f of x equals 2x cubed. Find the derivative of f of x, which is equal to 2x cubed minus 7x plus 5. So in this unit 5, there's the power rule. You take the exponent of x multiplied by the coefficient, the number in front. 3 times 2 is 6. And then you subtract 1 from the exponent. So x, 3 minus 1 is 2. And then this is x to the first. 1 times negative 7 is negative 7. 1 minus 1 is 0. X to the 0 is just 1. And then the derivative of a constant is just 0. So the answer to this, I'm not getting a good draw on my pen here for some reason. The answer to this is 6x squared minus 7. That's the derivative. Okay, that's number 12. I need number 13 now. 13 is cha. These all have to do with derivatives. You can use the quotient rule, and I don't know if in this chapter that it has a quotient rule in this class. So I'm just going to rewrite this as 5 times x to the minus 1. This is x to the first in the denominator. I can move it up into the numerator by negating the exponent, and then plus 7, and same way with that, x to the negative 2. Now I can use the power rule. I move this up into the numerator, so I negated the exponent. So I'm going to use a power rule. Negative 1 times 5 is negative 5, and then negative 1 minus 1 is negative 2. Negative 2 times 7 is negative 14. Negative 2 minus 1 is negative 3. And now I will put these back into the numerator. If it's in the numerator, rather I'm putting them back in the denominator. If it's in the numerator, I can put them in the denominator and switch the sign of the exponent. So this is negative 5 over x squared minus 14 over x cubed. And it's this one. And now question 14, I believe, is going to use applications of the derivative. I better check to see if I'm recording. I am. Application. So it says, given f of x equals x cubed minus 12x plus 5, answer these. Is a function increasing or decreasing at x equals 3? Well, find the derivative and then plug in 3. So f prime of x equals, I'm going to use a power rule. That's a 1. 3 times 1 is 3. 3 minus 1 is 2. So 3x squared. This is 1 minus 12. 1 times minus 12 is negative 12. Did I say 3? I said 3 minus 1 or something. It's 3 times 1 in the first one. 1 times negative 12 is negative 12. 1 minus 1 is 0. X to the 0 is 1. And the derivative of a constant is 0. So this is 3x squared minus 12. I will plug in 3 because I want to know if it's increasing or decreasing. If the derivative is positive, increasing, negative, decreasing. 3 squared is 9. 3 times 9 is 27. Minus 12 is positive. It is increasing. Then it says, list the interval where f of x is decreasing. Well, I'm going to take that derivative, 3x squared minus 12, set it equal to 0, find out what the answer or answers are, and then set up intervals and test some number in each interval to see if it's increasing or decreasing there. So this is 3x squared equals 12. X squared equals 12 divided by 3 is 4. X equals plus or minus 2. So my intervals are going to be negative infinity to negative 2, negative 2 to 2, 2 to infinity. And I'll use negative 10, I'll use 0, and I'll use 10. So negative 10. Negative 10 squared is 100. 3 times 100 is 300. Minus 12 is positive. In that interval, from negative infinity to negative 2, it is increasing. 3 times 0 squared is 0. Minus 12 is negative, so it's decreasing from negative 2 to 2. And 2 to infinity, 10 squared is 100. 3 times 100 is 300. Minus 12 is positive, it's increasing. So it is decreasing from a equals negative 2 to b equals 2. And now, at what value does f of x have a relative maximum rather? It will have a maximum where it's increasing and then decreases. It would have a minimum if it's decreasing then increasing. So the relative maximum is going to be at negative 2, x equal negative 2, because before it was increasing, after it was decreasing. Relative minimum at 2. Before 2 it's decreasing, after 2 it's increasing. So now I will just look at the graph. Here's a graph, x squared minus 12x plus 5, and you will see, here's all the answers. Because I'm doing this like homework. Can't do this on the test, but I can do it here. Let's see, at x equal 3, somewhere around there. Well, I can't get it exactly. Oh, there it is. You can see it's increasing. The graph is going up at that spot. And then relative minimum, or it's decreasing from -2 to 2. See, and then it starts increasing again. And then it's a relative maximum, a peak at x equal -2, and relative minimum, that wasn't asked, at x equals 2. So all questions about derivatives on this pre-calculus Onramps review have now been answered.